All right, let's kind of summarize our little lesson on introducing conics. And so 3 conics we've talked about today: circles, ellipses, hyperbolas. We're going to get into parabolas in the next lesson. They're pretty easy to identify. If you haven't already, I would encourage you maybe pause this and write this down, what I have on this on the screen right now. This just helps us identify what type of conic we're dealing with. And this was in the lesson, but I just tried to summarize it. So circles, squared terms are added together, and here's a key: they have the same coefficient. Ellipses, very similar. Squared terms are added together, but here's the difference: they have different coefficients. Okay, ellipse is longer on the side of the squared term with the smaller coefficient. So if the x squared term is smaller, then it's longer in the x direction. If the y squared is smaller, then it's longer in the y direction. Hyperbolas, squared terms are subtracted from each other, so these are really easy to see from their equation. If the x squared term is positive, then the hyperbola opens left and right in the x direction. If the y squared term is positive, it opens up and down in the y direction. Okay, let's go look at an example of each of these. So sketch the graph. Now on your multiple choice practice assignment today, it's going to have you identify graphs, but here's what I want you to do. I don't want you to go sketch things by hand. I want you to use Desmos.com. Okay, so sketch the graph. Now I hope looking at this, we can tell what it is. Use our guidelines on that previous slide, right? Added together, different coefficients. Hey, this is an ellipse. Smaller coefficient on the y, so it should be longer in the y direction. Let's graph this on Desmos and see what we get. So you can just type it in. I'm just using my keyboard on my computer. So 25x squared plus 4y, and I'm just using the caret symbol on my keyboard to do those exponents. That's how I'm doing that. There are buttons on the calculator I realize you can use, but I usually find it's easier just to do it right on my keyboard. Hey, there is our ellipse, right? And I can zoom in and out a little bit, kind of move it around there. So there's our graph. State the domain and range. All right, let's talk about that. Well, here it goes from -2 to 2. All right, so state the domain and range. So if I go over, let me just click here, get my pen real quick. So what's the domain? Remember, that's all the x values that it could take. And so it goes from -2 to +2. X is everything in between -2 and 2. How about the range? Well, you can just click here, right? It's everything from -5 to 5. And so that's my y values, -5 to 5. Okay, not too bad. How about x and y intercepts? Well, of course, x intercepts where it crosses the x-axis. Hey, it's -2, +2. So for x intercepts, I've got -2, 0, and 2, 0. For y intercepts, I've got, you can look over here, I've got -5 and +5. So I've got 0, 5, and 0, -5. Not too bad, right? Okay, let's go do another one. Let me wipe out this graph. Sketch the graph. Well, notice these are subtracted. Hey, that's got to be a hyperbola, right? But again, we're just going to type it right into Desmos. And notice the y is first, it's positive, so that means it should be opening up and down in the y direction. Let's go type it in. So y squared minus 2x squared equals 16. Hey, there we go. Again, let me just zoom in a little bit so we can kind of see what's going on. Domain and range. Well, domain, again, domain is x values, right? There's no breaks as I go left to right. So the domain for this guy is going to be all real numbers. The range, on the other hand, well, let's look at it. There is -4, there's +4. It's everything except in between there. So let's describe that. So y is everything less than or equal to negative 4, or y is greater than or equal to positive 4. So again, it's everything less than negative 4, everything greater than positive 4. X and y intercepts, well, here's our x-axis, so there aren't any. Not x-intercepts, so none. How about y-intercepts? Well, we can see again right from our graph, right? Pretty slick. So we've got 0, 4, and 0, negative 4. All right? One more quick. I hope you're seeing, though, how powerful Desmos is and kind of what I want you to take from this. You could probably guess this is a circle because we haven't seen that one yet. But added together, coefficients are the same, you bet. We're dealing with a circle. Let's graph it quick. 6x squared plus 6y squared equals 216. All right? So there's our nice circle. Again, you can click on it, and it shows you all these points out here. 6 is around. What's the domain and range? Well, domain, -6 to 6. So again, let me just write that quick for you, kind of model how we would see that. So the domain is -6 to 6. X is everything from -6 to 6. The range, same thing. Except now I'm going to use a y value. Okay? X and y intercepts, well, again, you can just click on them out here, right? So for x, we've got -6, 0, and 0, 6. Whoops. I wrote that backwards. 6, 0. Sorry about that. So our y-intercepts, we would have 0, -6, and 0, +6. There's our y-intercepts. Okay? Not too bad, I hope.